In this video, I want to take a chemical reaction that I worked through before, and I want to help you visualize it with this system that I just taught you. As a reminder, this is what we're doing when we do conversions. We have a certain chemical represented as grams. We use the molar mass to change our representation to a molar one, because once we have it represented in moles, we can use the mole ratio to figure out how much of another chemical is associated with it. Then, because we want to end up with a description in grams, we use the molar mass again. But that's a different molar mass. It's the molar mass of the new chemical. I did this in a previous video, but now I want to help you visualize it. Now remember, we're going to need the molar mass of carbon dioxide, the molar mass of glucose, and the mole ratio between them. So let's get that. The molar mass of carbon dioxide, you look at the periodic table and you add up all the elements. Same with glucose. And the mole ratio between them you get from the chemical formula. So I'm going to start with 230 grams of glucose. And I need to take my representation in grams and turn that into a representation in moles. And I'm going to use glucose's molar mass. When I multiply by this fraction, I'm moving from grams to moles. Now what I need to do is transform this amount of glucose into the associated amount of carbon dioxide. And I use the mole ratio between carbon dioxide and glucose to do so. Finally, I have my molar representation, but I want it to be represented back in grams. So I'm going to have to multiply using the molar mass of carbon dioxide to take it back, because carbon dioxide is the chemical I have now. The way that you figure out what number goes on the top and the bottom when you're using the molar mass and the mole ratio is, again, part of another video, but you want to match the unit, so grams of sugar, that wants to be matched down here, grams of sugar. Glucose is sugar, by the way. Moles of sugar, moles of sugar. Moles of carbon dioxide, moles of carbon dioxide. So once you actually have your fraction set up, and you are where you want to be, in this case you're representing your final chemical in grams, then you put it in the calculator. 230 times 1 over 180 times 6 over 1 times 44.01 over 1, and you get your answer. 337.41 grams of carbon dioxide. So I hope this helped you visualize exactly what these fractions are doing. It's not math for the sake of math. Every single multiplication step represents a real process that you should hopefully be able to visualize as you're solving them.